In the previous exercises, we wrote down the reasons for these statements, right? And so now what we need to do is write two-column proofs, but these are now geometric two-column proofs, where we have our givens, right, and our figures, and we write our two-column proofs. Notice here, I didn't number my statements, but I should have. It should have been 1, 2, 3, 4, 5, and 6. And this is 1, 2, 3, 4, 5, and 6, like so. And we start with our given, right? So all of these statements are our given. We have our first one here, got our second one here, and our third one there. So this is going to be A, B, right? And so notice I separated them with commas and put them all in the same statement, and I wrote given as my reason. And then what did I do? I started using my algebraic properties, because remember, the measure of line segment AB is just a number. The measure of line segment CD is just a number, right? And the measure of AB is equal to this algebraic expression, which represents a number. And the measure of CD is the length of CD. That's a number, right? So we can go ahead and use our algebraic properties in order to get to our proof. Right? The same thing over here with our measure of angle ABC. Right? The measure of the angle is not the drawing in the figure, the ABC angle. It is the number of degrees in this angle. Right? So this measure of angle ABC is a number. Measure of angle CBD is also a number, which is why we can say those two are equal to 90. And we can use our algebraic properties to manipulate them. Oh, and again, I didn't number my statements, though I should have. And yeah, that's what we want to do here. And so here's something that I want to go over. So here we have geometry, can use the properties of algebra, right? But before we do, we need to change any statements involving congruence, like right here. Do you see this? To equations using the definition of congruence as our reason. Okay, so notice here, what are we given? We're given line segment PQ, right? This is different than this expression here, which is the measure of line segment PQ. This here is a number. It's the length of this line segment. This here is the line segment that's drawn in the figure, right? So this is saying that line segment that's drawn over here in the figure is congruent, is the same length as this line segment drawn in the figure, right? That's what this is saying here. And line segment QS is congruent with line segment ST. So this is saying in the figure, this part is the same length as this part over here. They're congruent. Right? These here are not numbers. These are portions of the drawing, right? Portions of the figure. It's not until we get to measure of line segment PQ that we can use an equal sign, and we could say it's equal to measure of line segment ST, because these two are numbers. So how do we get from congruence to equal sign? Well, we're going to start with our givens, of course. And then our second statement is going to convert the congruent statements into equal signs. Right? And what's our reason for being able to do that? It's definition of congruence. Right? So we're going to put definition of congruence. And then we're going to go ahead and use an algebraic property to get to our proof statement. And this is going to be transitive property.